This is a small video showing how to align scans in reverse engineering. One of the very important parts of reverse engineering is to scan the object, and you normally get more scans and you have to bring the scans together. And this is what we are doing in the so-called Align1 software, which reads in different polygon scans, polygon models, point clouds, and bring the point clouds together. So let's try to take a look at the first image. We import a so-called PMGX image. We take the H1, which is the first one, which is a head file. We don't have to look at this every time, so we take it in. We accept the parameters. This is the image. We accept the parameters. Now we interpolate it. We say done, and I just say OK, and now we have the image. And this is an image consisting of pure points. If you look at this one, you'll see this is, we don't want to look at it as flat, we want to look at it as points, and we want the points to have a point size, pixel size of 2. Now get closer to the image, you'll see very clearly that this is points. So we have a lot of points in this image, and these are all based on the point cloud, which was generated by the scanning. So let's go back to the flat image again and say this is our first image. Now let's import the second one. Import image PMGX. So now we're going to take the H2. Open that one. And again, accept the parameters. Let's say done. Let's say yes. And now it's quite clear then, because scanning of the two, these are two different scan clouds and they were taken from different orientation, and that's why we get this not orientated, and that's what we want to do. So now we use a function, the so-called split view alignment. That means we split up the two views, the 2 point clouds. This is the newest point cloud, this is point cloud 2, this is point cloud 1. We just orient them approximately with the mouse in the 2 view windows. With the middle mouse button we can move around in both images. With the middle mouse button we can zoom in and out, and we can rotate with the left mouse button. So now this seems to approximately right, and we just use the so-called automatic alignment. I can do it fast, I can do it very, very accurate. So I decide in this case to make it fast because we don't have that much time, and say start, and now he calculates on it, and we go back to the split view alignment and see now the two images are brought together. Very accurate, and this seems to be a quite accurate alignment because you have a mix of colors. We have yellow and blue mixed in a very nice way, so this seems to be okay. So let's take the third image file, we import an image, PMGX, we take the H3, open that one, say OK. Now process the point cloud, say done, yes. And again, same story, this is copper based or copper colored. We can split it up and we get the newest one to the right. We just have to orient it just approximately as the left one, just like this. And so now it looks to be okay, and we say start, and now it's aligned. So in this way we continue until we have the whole model aligned and read in, and then we actually aligned all our point clouds. After the alignment we need to make a so-called best fit alignment. That means we take the 3 point clouds and try to get them as close as possible to each other. So this is the maximum distance. I mean, every point cloud that's more than 2 millimeters away, we leave them out. We only subsample every 4 points, or we can take that and say we want to look at every point. And in the next window we get the statistics. So let's just start it up. Now we get the statistics. He did it already, and this is the standard deviation, and we see the maximum standard deviation is approximately 0.1 millimeters, which not should exceed the accuracy of the scanner, which is 0.2. So this is okay. So this is aligned and optimized scan cloud. If you look at a histogram, they look okay, they are normal distributed, and this is exactly what they should be. If we have 2 peaks on it, then we have a problem with the scan cloud. Then we have to delete it and make it from the beginning again. Yeah. What's left is to make a so-called smoothing. That means you have to take the 3 point clouds and we make them active, we select them all, we go into image, we choose the smooth, And this is split up in two areas. A low curvature parameter, that means every radius larger than 30 millimeters is treated in this area, and in the high curvature area we have different parameters. A very important part of this one is a filter radius. That means this is the size we're looking at. We have a radius of 3 millimeters, and inside that area we look at all the points, and the points that are really too much away or too far away from the average, we lower them with the tolerance and approach them to the average with a maximum of 0.15. That means 0.15 is a maximum distance we're going to move the parameters, or moving the points, each point. So this is going to smooth the surface. Normally it's recommended to just leave the parameters as they are, because Polyworks is calculating the needed parameters on its own, so normally they fit quite well. So say apply. Now we start to smooth the model. Just take some time. And now watch the difference. Like this. So this is the smoothed model. So it gets much more soft, and it took away a lot of problems at the surface of the model. So I can close this one down. Now I can take and close down, for instance, H2 and H3. I just say we don't want to keep them, we want to hide them. So now this is the H1. So if I import the H1 now again, import image, I want to import PMGX, I want to look at the H1, open that one. Now we see the difference between the smoothed part and the original one. So let's take a look at this one. So here it's quite clear. You see very clearly what has happened. Originally we had the green shape. After the smoothing we got the blue one. So you see very clear, for instance, what happens in this area. It took all the extremities and brought them down to the surface. So this is what smoothing is doing. Smoothing is simply taking away all the outer part of the point cloud and move it into the so-called average point cloud. So this is smoothing, and it's very useful in alignment. That was ending the session, alignment in reverse engineering.